It's an honor to introduce tonight's lecturer, and also to thank a couple of organizations that have chipped in. We are co-sponsored tonight by CSI Iowa, the Construction Specifications Institute of Iowa, for reasons that have become very apparent as the evening goes on. And we are co-hosting with Iowa State's Department of History, who have also been interested in Jessica's work. That covers a lot of territory between Construction Specifications Institute, Department of History. That, I think, speaks to the truly interdisciplinary work that we're going to see tonight. Jessica Garcia Fritz earned her Bachelor of Arts in Architecture and her Master's of Architecture at the University of Minnesota. She worked for O'Neill Langdon Architects in New York City and as an exhibit designer at the Smithsonian's National Museum of the American Indian, where she designed and built exhibits with a socio-cultural and historical focus. She is a founding faculty member at the Department of Architecture at South Dakota State University, where she teaches studio history and also manages the architectural library. With Federico Garcia Lammer, she practices with LA-BOR, an office that, quote, makes images, objects, buildings, and texts, focusing on the impact of media on architectural labor. That is a great office description, and I'm kind of envious of that. LA-BOR's research interests range from the politics of building regulation to the impact of invisible workflows. And her current work on vaulting includes digital and physical reconstructions of historic vaulted structures, and this includes the captivating rediscovered art of the shallow masonry vault that, as we'll see, was perfected by the Guastavino family in New York at the turn of the 20th century. In this, she is not only an architect and a scholar, but also a construction historian. This is a field that is profoundly cross-disciplinary and includes people from engineering, architecture, law, history, et cetera, et cetera. We who call ourselves construction historians often joke that we do history with our sleeves rolled up. Jessica's work and that of LA-BOR is certainly that, but also history with its boots on. And it is a great pleasure indeed to welcome Jessica Garcia Fritz to Iowa State tonight. Please join me in welcoming.
Thanks, Tom, for that introduction. Thanks to the Department of Architecture, the Central Iowa chapter of the CSI, as well as the ISU Consortium for the History of Technology and Sciences for inviting me here tonight. Thank you all for being here. I want to share with you some work that is still developing. It's rather new, but also old. It's based in the Guastavino Company. And this work is part of the ongoing work that my partner and I are looking at. And it's part of our academic work as well as our work in practice. Specification writing. It's often viewed as one of the most mundane procedural tasks of building design. It's often reduced to an administrative task or little more than a legal requirement. Specifications today are, many times, they might be downloaded from a manufacturer's website or they are externalized to consultants. While drawing sets and models describe physical work in place, specifications direct work through the selection of delivery methods, building systems, materials, and labor within local and global economies. Therefore, specification writing is one of architecture's most social and political acts. In architecture, technological systems have historically been associated with the development of physical artifacts. So these are mostly buildings, materials, drawings, models. Technological systems may also include organizations, regulatory laws, and agreements. This is a fantastic organizational chart for Albert Kahn Associates. And one of the things that's really striking about this image is that all of these departments come together primarily through specifications. which of course is a big rectangle in the diagram. If technological determinism positions physical artifacts as determinants of what we do, then technological systems combine both physical and non-physical artifacts as both socially constructed and society-shaping components. So it's important to note that with technological systems, when we look at building systems such as balloon framing, masonry vaulting, thin concrete shells, the reason why they might be successful or not successful in history may have emerged more from patterns of agreement rather than pure scientific achievement. Specifications are socially constructed artifacts within larger technical systems, and they are political because in their capacity to select methods of work, building systems, and materials, they must leave others behind. There is Raphael Guastavino, Sr. In the United States, one of these building systems were the thin ceramic tile vaults, structural vaults, constructed primarily by the Guastavino Company. The spoiler alert, the story does not end well for the company. In fact, they closed their doors in 1962. And of course, I can divulge this to you because we're going to go deeper into the company's specifications. At the start of the 20th century, the architecture and construction community embarked on a radical restructuring of agreements and organizations that govern the social, economic, and labor culture of building sites, primarily through specification standards. And as optimization of building sites arose, so too did precision in specification writing. And this was reflected primarily in the specifications that were written for the Guastavino Company. And I say that because they were not architects. Specifications written for the company between 1900 and 1940, so the early part of the 20th century, refer to the exclusive selection of what's referred to as Guastavino work. And I put that in quotes because it's not a term that the company invented. Guastavino work is a comprehensive term for translating the company's very skilled labor, their skilled vaulting construction, as well as tile manufacturing into written directives. Subsequent specifications written between 1940 and 1962 for the company introduced subcontractor work into the specifications. So the Guastavino Company was no longer referred to as a master builder, and their work was no longer referred to as Guastavino work. Instead, they were referred to as subcontractors. And this is a standardized term in construction used to define work performed by various trades. Ultimately, what this terminology shift indicates, it's written in the Guastavino Company specs, is it indicates that the shift from Guastavino work, which was exclusive in the selection of their work, to subcontractor work, which becomes this broad term in the context of construction. It begins to reflect and indicate rising standardization and professionalization in the early 20th century architecture and construction community. So I should note that this image that you're seeing, again, there's Raphael Guastavino Sr., and he's standing on an arch for the Boston Public Library project, which was one of their first commissions in 1889. And I say that they're not the architects because of McKim and White. Of course, they were the architects for this project, and the Guastavino Company was responsible for constructing these arches and vaults. On March 16, 1985, Captain John Sewell, the Corps of Engineers, submitted his specifications for the reconstruction of the Washington Barracks at the U.S. Army War College to his boss, Brigadier Alexander Mackenzie. And Alexander Mackenzie, there's his name right there, he is the chief of engineers at the time. Sewell, when he sends and submits the specifications to his boss, he accompanies the specifications with this letter. And in the letter, what Sewell says is he said, this is really the only company that has the expertise to construct this type of system. So he begins by saying all this, and then right here he says, there is no patent on the type of arch herein described. There is no reason other people should not do such work if they want to, except that it requires special skill and experience. And I'm satisfied the Guastavino Company is the only concert in the United States at the present time possessed of this skill and experience. So Sewell, he recognizes the expertise held by the Guastavino Company, and he qualifies them for their exclusive skill in constructing structural masonry arches and vaults. And although later in the letter he does agree to advertise the work for 2 weeks, he ultimately establishes his own agency as the engineer of the project to select Guastavino work for the project. Much knowledge already surrounds the vaulting system that Raphael Sr. brought from the Catalonia region of Spain when he immigrated to the United States in 1881. The discussion around this work will revolve primarily around this timeline. So there is Raphael Guastavino Sr. So I'm going to jump around a little bit. It's chronological, but I will discuss this in a non-chronological way. Once in the United States, Raphael Guastavino Sr. introduced the system to early projects such as the Boston Public Library that we saw back here. In fact, in 1889, this was one of the first projects that introduced the system to the public. It was of course, on a civic scale. So Guastavino, he doesn't invent this system. It had been around the Catalonia region of Spain since the 15th century, and of course it had existed before that time. It's simply that Guastavino brings it to the United States. And after he receives this commission for the library project and constructs the vaults, other projects ensued over the course of 70 years, which is what you see here in these white boxes. These are all projects of the company. The system has been the subject of many studies, as I mentioned, by many scholars. What the system is primarily known for, oh wow, the resolution. What it's primarily known for is how thin the system actually is. So here you can see that it is comprised primarily of 3 layers, but these vaults and these arches and domes could span large spaces. This dome, for example, that you see the tip of the Cathedral of St. John the Divine spanned 208 feet. It was one of the company's biggest commissions and largest vaults to date. The system has become the subject of several workshops, and this is one that we had worked on with Benjamin Sevilla. He came to the Department of Architecture at SDSU in 2013. And the construction system, you can see the breakdown here, that it's something that can be constructed with little to no centering. So we begin by making these really thick columns. A first layer is put down for the arches. The arches are constructed first. And what you're noticing in this image is that the first layer of the shell is put in place by fast-setting plaster of Paris. This is a big reason for why it could be constructed without little to no centering, is because the plaster of Paris, of course, it sets quickly, and each subsequent tile can be put in place. Once that first layer is complete, a second layer of tile is placed over the top of the first using mortar. And the approach of the company was to put a layer underneath the primary vault. So there would be a finishing tile that was put into place. This is primarily what constitutes Guastavino work. Of course, ours is on a smaller scale. The span, here's somebody for reference. The span of this vault is about 6 feet. And when Benjamin came, I convinced him to build the vault on a pallet, on 2 pallets placed together. We drove them together. And one of the things that we wanted to do is we wanted to figure out a way to record how the vault could be broken. So it's South Dakota, so we brought in a forklift with a pallet full of salt. and it was salt bags. And of course, these are always put up across campus for the winter time. And the forklift, we brought it in, we put it on top of the vault, and as the forklift was lowering the pallet, the forklift began to tip over onto the vault, but nothing happened. So we couldn't figure out a way to place this vault in under so much compressive force. What broke the vault is the forklift. When we placed the forks into the pallet, it destabilized, and ultimately, when these two columns were spread apart, the vault fell. So it's incredibly strong in compression. And as I mentioned, the term Guastavino work, it wasn't coined by Raphael Guastavino Sr., nor was it coined by his son, Raphael Guastavino Jr., which can be somewhat confusing, so I'll try to keep them straight. Guastavino work, it first appeared in specifications written for the company's subsequent projects. So it was a term that was used by architects. So the Boston Public Library Commission helps launch the company and Guastavino work. But Raphael Guastavino Sr. and his son, Raphael Guastavino Jr., they ensured extra protections for the system. And together, the two of them filed U.S. patents for some of their inventions. This occurred between 1885 to 1939. And what these 24 patents reveal, they expose a young company that evolved from the inventions of both father and son. The first patent that was filed was, of course, by father, Raphael Guastavino Sr., and it was for the construction of fireproof buildings. And what he did is he presented a partition that could be used for projects as small as a single dwelling, and it could also be used in large-scale projects like theaters. And of course, in the early 1900s, this was a large concern, how buildings could be fireproofed. And initially, the company was known as the Guastavino Fireproofing Company. And Senior was very good at selling architects on the fact that these were fireproof structures as well. Other types of patents that were filed included cohesive construction processes. And in fact, it's Senior who referred to this system as cohesive construction. He wrote about it as cohesive construction. Tile arches were also patented for ceilings and staircases, building tiles, a kiln for glazing tiles, so they were able to patent those inventions, masonry structures, and later, Raphael Guastavino Jr. had patented acoustical tiles. So not only were the tiles fireproof, but they could also, Acoustalith, which was their product, was also used for soundproofing. And finally, of course, plaster projects. So in the later years of the company, they really upheld the products for soundproofing, and they were used in a variety of infrastructural projects. Nonetheless, all these patents solidified the skilled processes and the unique materials that the company was able to advance. And I should note that many of you actually might be familiar with the projects constructed by the company. If you've been to New York is full of Guastavino projects, including Grand Central Terminal, the Oyster Bar, the Visitor Center in Ellis Island. If you've been to Nebraska, the Nebraska State Capitol, the Dome is a Guastavino Dome, the Minnesota State Capitol, etc. And I believe there's projects here in Iowa as well. And I have to find out. This book that I am showing to you, this is John Oxendorf's Guastavino Vaulting, the Art of Structural Tile. And this is a book that offers a comprehensive look at the history of the company and the system. So I'm not going to get into, I'm only going to touch on how the structure works. I'm not going to get into the discussions that John has because he's covered it. This is more of, if you would like to see more information, you should certainly check out this book. What Oxendorf also does is he touches on this systems approach that the company took. And what this approach refers to is the management, construction and manufacturing of parts of buildings. What John also argues in the book is that the systems approach runs counter to the growing professional specialization in the US in the early 20th century. So this is really where this study broadens and where my study begins. In the book, John, he foreshadows somewhere in here, he has a whole chapter dedicated to the decline of the company. And he foreshadows the decline of the company by acknowledging the reduction of the original structural system to a purely decorative system. So in later years, the specifications written for the company, they do select the system, but the selection of the system is more of a decorative system rather than the original structural version that we saw in Boston. However, Oxendorf, he attributes the decline of the company primarily to codes, but he doesn't really expound upon codes or agreements in the chapter. So this study, it's built off of John's book and his previous arguments by examining the patterns for selecting work performed by the company via their specifications. And by positioning these patterns within the larger context of the early 20th century architecture, that we can take a look at how these specifications begin to reflect the growing professionalization and standardization in the architecture and construction community in the United States. All right, these are all the specifications for the company. And after the company closed in 1962, Professor George R. Collins, he arranged to have all the papers from the company, the drawings, specifications, any manuals from their main office in Woburn, Massachusetts, donated to Columbia University. So if you go to Columbia, check it out in the archives, the drawing archives, the whole collection is there. And what these records acknowledge is a major role the company played in the United States as master builders of faulty technology. So master builder, this is a term that doesn't really exist anymore in construction. They specialized in parts, but they were really well known as master builders in the early 20th century. The collection is actually fairly light in its documentation, considering the total production of the company. And again, the company, they had projects throughout the United States, primarily on the East Coast, but they did have projects throughout the United States. Drawings exist for only 70% of the company's work. And when I spoke to Janet Parks, who is in charge of the archives, so she's documented the archives, she's written about the archives. When I met up with her and spoke with her about why certain documents might be missing, she said, well, that's what happens when a company has a kiln. You just throw documents into the fire. What Janet also noted was that the company specialized in parts of buildings. And this is what's perhaps a little bit difficult about studying the company is that architectural historians, they look at buildings as a whole, they might look at complete documentation. With this company, because they're not architects, they're looking at parts of buildings, it's a little bit more difficult to place them within certain projects. However, across multiple projects, certain and specific documents do exist. And of course, specifications are one of those documentation types. So for this study, 40 specifications materialized in the collection. They were discovered, they were collected and analyzed according to terminology and formats used to describe Guastavino work. And over half of them exclusively refer to the faulty technology as Guastavino work. So the four tables that you see right here, I'm going to speak a little bit more about these types. But if you can read the small text, I'll just point a couple of things out of here. Anything that's bolded is a direct reference to the Guastavino Company, to the structural system. Here is the Guastavino Company in certain titles. Here is the exclusive specification of the company. And finally, I'm going to talk about this one a little bit later, because this is Guastavino as subcontractor. advertisement for the Guastavino construction. In examining technological systems, the social construction of technological systems perspective, this is a theory that comes out of sociology. And I'm by no means a sociologist, I'm just touching on this theory. It tells us that social groups, rather than individual inventors, construct new artifacts and systems through the agreements they make with one another. So really, artifacts such as buildings, drawings, they have no agency of their own. They're simply the material reification of social agreements. And the Guastavino Company primarily advanced Guastavino work through agreements that they had with architects and engineers. And these specifications that I just spoke about, and we'll look at a little bit more, worked as social agreements for selecting and determining modes of Guastavino work. A surviving salesman manual offers some idea of how Guastavino work was discussed. So when salesmen went out to sell the product, whether or not it was the tiles or the installation of the tiles or the vaults, the arch, salesmen were instructed not to give quotes or estimates to potential clients. In fact, this was the work of engineers. So engineers would calculate the structure, and then they would calculate how much it would cost to install the vaults or the arch. Second, the company, they did not sell tile unless they were the ones that installed the tile. So this was actually a very smart move by the company. And because they had projects throughout the United States, they would hire local laborers to build vaults and domes, but they would send a company's mason out to supervise the sites. And I think the third part of this is that mason would frequently send progress reports back to the company, either for a day's work or for a week's work. And so they would tell they would refer to somebody, another mason or an engineer in the company, and say, okay, we completed this much of this section of an arch or a vault. And from a social construction of technological systems perspective, technology is shaped more by the need to preserve social and political agreements between producers, governments, and consumers, rather than conforming to seemingly objective science. So the company's systems approach, this is the approach that John Oxendorf was touching on, and an approach that was also supported by the letter that you saw written by John Sewell. It shapes the exclusion in specifying Guastavino work. So looking at the specifications written from the Guastavino Company, and I'll get into some of these projects in more detail. It offers insights into the impacts of standardization and professionalization in the early 20th century United States. So I'm going to talk about that a little bit later on, and how these specs reflect some of the growing standards in our profession. When examined as a collective, there are three primary patterns that emerge across the specs. One, all of these projects are of various typologies, and they were constructed at various scales. So churches, cathedrals, secular buildings, infrastructural projects, all implemented the vaulting system. So across all four of these categories, there's St. John the Divine, which is one of the largest domes that they had constructed. It was for a church, but again, they've also constructed projects, military projects, and secular projects as well. The second pattern that emerges is that the vaults were designed and specified by a variety of architects. In fact, across all of the specifications, certain architects, their names only pop up maybe twice at most. Of course, Raphael Guastavino Sr., he worked extensively with McKimmey and White, and only a couple of specifications exist for their projects. Most of these projects were constructed within the time frame that Raphael Guastavino Jr. had ran the company. So it was really Jr. that kept most of the documents. The third pattern that emerges is that Throughout the United States, from 1905 to 1962, all of these projects were constructed in a variety of locations across the United States. So as I mentioned, Nebraska, Minnesota, we don't have any in South Dakota, but certainly there are some in New York, Massachusetts. Primarily, they were constructed along the eastern seaboard. But in the diversity of the projects, the locations, the architects who specified the work, none of the clauses within the specifications repeat themselves. And of course, if a variety of architects are specifying the work, that can be well understood, that there's really no repetition that exists. But what's somewhat unusual about this is that the Guastavino Company didn't have a standard for how to specify their work. They didn't offer a standard clause or clauses for specifying the work. So terminology was not recycled from specification to specification, likely due to the diversity of vaults and arches that were constructed. And they were managed by the Guastavino Company on site. So the skilled labor of the company was primarily entrusted to the company. Another pattern occurs primarily in the formats used for defining Guastavino work. So before standards and specification writing, which was primarily put forth by the Construction Specification Institute, which was formed in 1948, post-World War II. Before standards in writing, architects and engineers, they assumed the primary role of categorizing various technical systems on site. And in the early 20th century, it was okay to do this because most technical systems involved masonry, carpentry, or some cross of the two. And what this means is that similarities began to develop across the various formats, especially in this work. And 32 of the 40 specifications written for the company could be categorized according to their formats. Not necessarily the exact language that they used, but the formats that they used and the way that they began to address Guastavino work. And these types, they fall along the side. I'll go into more detail here, but they form these categories across the timeline. So you're seeing that this group of projects, they're categorized according to the Guastavino similar category. These projects right here exist within the Guastavino only category, and these projects here exist within the Guastavino the title category. This last category, I'm going to step back, but I'm going to talk about it a little bit later because it does exist as a fourth. This first category is Guastavino or similar. It's the first type that occurs throughout a good chunk of the specifications. Guastavino appears in the body of the specification, but they're only alluded to as a company. So these are specifications that refer to the company directly by name within the body of the specification. So it's not within the title of the division, not within the title of the spec. And what this means is that the specification, it opens work to multiple contractors so long as the contractor could construct the vault or the arch similar to the Guastavino Company. Cathedral of St. John the Divine, and this is for the nave. So there is two parts to this project. The nave vaults were constructed in 1927, and they were constructed by a different architectural firm. They were constructed by Cram and Ferguson Architects. I'll read this because I see it's a little blurry. What it says is that the construction of the roof shall be of what is known as the Guastavino system of construction. And what Cram and Ferguson, what they do as architects, they are they're exclusive in their selection, but they are also selecting the type of construction and only alluding to the installation by the company. So what they're saying here is that the Guastavino system is what needs to be used. Our Guastavino Company, they don't necessarily have to do the installation, but if you can make it like the our Guastavino Company, perfect. The second category, Guastavino the title. These are specifications that are a little more broad in their many versions, to the extent that many subcategories could be derived. But Guastavino always appears in the title of the specification or the division. They use a variety of terms in specifying Guastavino work. And the other part of the Cathedral of St. John and the Divine, the crossing, it implements the Guastavino Company's work. And in the title, they directly refer to Guastavino work. In fact, this is where the term Guastavino work comes from, this and other specifications like it. The title of the spec is Guastavino work for the main floor construction, pendentives, and dome crossing. So Heinz and Lafarge were not explicit in naming the company, although they do imply some type of exclusivity via the title of the specification. And the final type that I'm going to talk about right now, until we get to Guastavino as subcontractor, is Guastavino only. This is a third type that appears in the body of the specification. And this is the type that refers to the company directly by name. And it establishes the exclusive selection of the R. Guastavino Company or a Guastavino built work. It's very exclusive in the selection of the system. So I'm going to dive into this specification a little more deeply. This is the Cornell War Memorial, the University War Memorial. And Charles Z. Clowder, the architect for this project, which was constructed in 1928, he eliminates competition for material manufacturing as well as the system by stating, where shown on the drawings erected by the R. Guastavino Company of New York and Boston. So there's a little bit of in between. He sees the ... that's here, refers specifically to the ceiling bolts that are to be constructed of the timbrel tile. So this is very exclusive in its nature. And when we look directly at the specification, we can begin to see how the variety of roles on site began to work with one another. Because of the exclusive nature of this type, this format deserves a closer look. Ultimately, what this one-page specification does for Guastavino work, it demonstrates a hierarchical social organization of Guastavino work on site. The specification defines work for the bolting contractor, which in this case, of course, is our Guastavino Company, for the stone contractor, for manufactured materials, as well as the general contractor. So the general contractor is a part, they are a member of the building site. And this foreshadows future relationships with general contractors. The company is directly addressed right here in the first paragraph. So I'm not going to repeat what was already said, but ultimately the spec goes on to say that the contractor's role, the bolting contractor's role, is to provide centers as well. So the work is laid out for the company. The stone contractor's role is laid out as well. And they were to furnish and erect the stone diagonal ribs for where centers could be left. So the entire role is laid out. The material role is also specified. The bolts and arches should be no less than 2 layers of good hard burn, rough tile of semi-porous terracotta with a facing of acoustolith texture tile. Acoustolith is in all caps, not by my own choice, it's in the specification. But acoustolith is the product that was manufactured by the Guastavino Company. And it should be laid in a manner indicated on the drawing. So these Guastavino only types, they typically said, yes, Guastavino Company, and then referred to the drawings that the Guastavino Company was responsible for making. This specification also refers to the cement, how it was to be mixed, and cleanup, and also it discusses the raised joint, how high the raised joints of the mortar should be in between each tile. But I want to discuss a little bit in more detail the general contractor's role. So take a minute to look at this. And I'll read parts of it. The general contractor, their role was very different on a site that implemented this system. Their role was simply to provide support for the company. They were asked to leave recesses in the walls or build up pillars. So this is what they were supposed to leave in place for the company to come in and do their work. Down below, they're there to provide suitable scaffolding for the company. And what all of this variety of roles, what it alludes to is that the role of the general contractor, the stone contractor, material, their relationship with one another was merely there to support our Guastavino Company's work. So really they were the ones that were primarily in charge. What it also points to, beyond the hierarchical framework of the relationships on site, this also is something that points to the familiarity that the architect had with the system. Because they knew how it needed to be installed, but they didn't have to get into the specifics of the skill, labor, or anything of that nature. So as I mentioned, the story doesn't end well for the company, and eventually we know that they closed their doors in 1962, and the company no longer exists. And the question is, of course, why? What happens to the company? Why do they shut down? This is it's an amazing system that was brought to the United States. And of course, when people go to New York, not a lot of people know that they're standing underneath the Guastavino vault, but they're fairly awe-inspiring when you experience one. So the question is, why are we building like this? What happens to the company? Why do they shut down? And as early as the 20th century in the United States, when Guastavino work, of course, was continuing to be specified and selected, standardization and professionalization were taking shape in the architecture and construction community. And from 1880 to 1920 is a time when the construction industry embarked on issuing standards and specifications as an entirely new form of political control. This is an image from the Architecture of Error by Francesca Hughes. And it's showing the supervision of concrete being poured on site. So this is a narrative that is impacted by the introduction, of course, of new industrial materials. One of them is reinforced concrete. And what Francesca Hughes states in the Architecture of Error, I'm going to quote this, is that this vast body of legislation radically restructured the social, economic, and labor culture of the building sites. The vast body she's referring to are specifications and their standards. She continues to say that it's an often forgotten revolution, potentially matched only now by the role of augmented components, which promise to do away with construction itself. And the augmented components that Hughes is referring to, they materialize primarily through reinforced concrete, which is a newly industrialized material. Of course, concrete wasn't new, but it was newly industrialized, and it was attributed to as economic competition to Guastavino. So this standardization is something that is paralleling professionalization, and I'm going to talk about standardization first. What was promised by reinforced concrete was optimization. And optimization meant that standards through specifications could be formed. And this is what radically restructured the social organization of building sites. As professionalization in architecture began to remove architects from an artisanal classification, and what this meant was that the architect was removed from the site, not totally, but in greater detail. General contractors interceded to meet the management needs of the site. So architects become interested in reinforced concrete because it is a material that could be optimized and specified off-site. And these promises of precision, controlled uniformity, and quantification of every known aspect of production, again, it was a promise, not necessarily something that was seen through. It adhered to the malleable flow of reinforced concrete into the United States construction industry. And what we start to see in the United States, so starting in 1914, the American Society for Testing Materials, the ASTM, they began to form laboratory experiments. And as they formed laboratory experiments, they began to compose precisely written specifications for the production of the material. So as I read this, it can be the specification that can be performed, right? So samples must be placed on the number 200 sieve, which with the pan and cover attached is held in one hand in a slightly inclined position. It's moved forward and backward at the same time, striking the slide gently with the palm of the other hand at the rate of about 200 strokes per minute. I actually don't know what that rate is, so I'll just act it out. The operation is continued until no more than 1/10 of 1% passes through after 1 minute of continuous sieving. The residue is then weighted and then placed on the number 100 sieve, and the operation is repeated. So this is a report of the Committee on Standards and Specifications for Cement. 1904 was when this was written. Now remember, the Cornell War Memorial, the specification that was written for Guastavino work, is emblematic. It's a fairly good example of how Guastavino work was specified. But if you remember back to that specification, materials were never prescribed in full detail. Their installation were never prescribed. The thicknesses for the vault, of course, was counted on. The arch forms were described, but the tacit skilled labor of the company was never a part of the equation. And what these laboratory-produced specifications began to do, these ones that are written for reinforced concrete, they prescribe every motion and measurement that could be made by the laborer, as I have just performed for all of you. And what this means is that those motions, that labor, it could be translated to an unskilled labor force. Certainly economics was a factor in the rising selection of reinforced concrete for vaults in the United States, as Oxendorf also argued. Yet it's the restructured social organization of labor on site that also contributed. Historically, master builders like the Guastavino Company and laborers, they could effectively provide material science as well as quality control embedded in their knowledgeable, skilled labor. But precise standards that were introduced through written specifications created opportunities to transfer work to an unskilled labor force. So this was something that became somewhat ideal. What it also did is it reassigned the knowledge that was formerly held by skilled master builders and laborers. It reassigned knowledge to specially trained inspection personnel on site. So if we go back to this image, this is a specially trained inspector who is overseeing the process, the pour. Factory production of reinforced concrete propelled standardization to precisely written specifications. And of course, I cannot mention factory production without speaking about this book, which is a very small one, The Principles of Scientific Management, published by Frederick Winslow Taylor in 1911, which of course establishes Taylorism. But in the book, he offers management principles for replacing what he refers to as rule of thumb systems. And the Guastavino system may have been qualified as one of these systems. And what he says is that these rule of thumb systems, he says, should be replaced with studied and efficient ways to perform work. And these are the principles that allow investors in factories to better understand the total cost for completed production through a single contract. General contracting in architecture and construction, it follows suit. The approach, general contracting, first of all, it's the approach of drawing a single construction contract at a fixed price on a guaranteed delivery basis. And so what this establishment of these principles begins to do is it begins to seep into architecture and construction as well. So we see that there's a rise of general contracting, and the role of general contractor changes. So the shift now to professionalization. So us as architects, how did we let this happen, right? How did we lose agency on site? The role of general contracting and the general contractor, it leads us to this chapter in architectural history. And after the formation of the American Institute of Architects in 1857, United States architects moved to support professionalization, which was a foundation for representing a client's best interest. So architects were establishing themselves as representatives of the owner or the client, and they began to retreat from artisanal classification. Before professionalization, the building sector relied on skilled trades to carry out work on a separate contractor basis. So what would happen is, if I'm the architect on site, I would procure labor trade by trade. So I might say, hey, you're going to be my mason, you're going to be my carpenter, and I would procure and form contracts based on that trade, and then typically supervise the work. But single contractors began to attract owners and architects. As a result of this attraction, they faced a dilemma. One, they could continue to procure work by separate trade contracts, and they could supervise the construction. Or they could maintain a professional status by representing the owner. And what this meant is that they had to eliminate guaranteed costs and delivery dates because it was seen as a conflict of interest, that they might be padding their own pockets as a result of this. So what happens is the architects, they go forward with the second option of representing the owner, and an intermediate role develops, which is the role of the contractor. And what the general contractor could promise and what they could do, and he was typically a he in industry, could quantify units of work performed by various trades under a single contractor, contract with the owner. The general contractor could also supervise work on site. And the intention was that this general contractor would be on site, and the general contractor would have a variety of tradespeople underneath him. But that wasn't necessarily the case. What general contractors did instead is they went out and they formed other contracts with tradespeople. And hence the term subcontractor was a term that arose. So this is, of course, where the Guastavino Company, they become sidelined into this term. But I have to say that this approach came to general contracting. It came with resistance from members of the AIA. And during the 1906 AIA convention, there was a huge uprising in the convention. The chair of the committee on the relationship of architects to the contracting system, who was Cass Gilbert. And Cass Gilbert was an architect who's fairly well known. He is responsible for the Minnesota State Capitol and several buildings in New York. Cass Gilbert, he's on this committee, he's in charge of the committee. He is protesting general contracting practices. And what he says to all these architects is he says, okay, well, we're going to lose our agency on the building sites. And what's going to start to happen is that there's going to be a lower quality of work if we are not supervising the sites. So he's admonishing the comprised construction that would occur by separating trades from the architect. This is something that's further propelled by Wilfred W. Beach, who writes an article in 1917. And he writes this article, it's entitled The Problem with the General Contractor. And what Beach does is he supports this stance that Gilbert originally takes. And he says, the problem with the definition of the general contractor, according to the AIA, is that the definition says that the general contractor is in charge of supervising the operations of contractors instead of supervising construction. So they're merely there as a person who looks at agreements on site. Protests aside, general contracting holds sway in the United States, and of course it continued to attract the economic confidence of owners. Additionally, what's happening, at this point in time, so 1917, general contractors are receiving a wide variety of work, and they're not interested in organizing because they're all getting their own work, they're very happy in these contracts. What happens is there's a growing opposition from labor unions, and military contracts with the United States are increasing as a result of the U.S. entry into World War I. And what this does is it forces general contractors to organize themselves, and in 1918, the Associated General Contractors of America formed. So that's the line that you see right here. And although the impacts of professionalization, they grow slowly from 1857 on, many architects they still hold contracts with master builders and tradespeople. So you can see that a variety of these projects are specified and they are constructed post-formation of the AGCA. So it's not something that really catches on, general contracting does, until the beginning of World War II. Cass-Gilbert's warning of the growing distance between architects and the tradespeople, it manifests. And it manifests through less physical interaction between architects and tradespeople on site. And as socially constructed artifacts within the architecture and construction community, specifications were the agreements that still allowed architects to maintain written connections to the building site via written directives. So for architects, the physical separation from the site, coupled with communication through written directives, perhaps sweetened the appeal of optimized materials such as reinforced concretes. Because there was an assured precision and uniformity in the materials made possible through quantifiable measuring and installation processes, this could be translated seamlessly to written word, as you saw, where every motion of the laborer could be laid out. So selecting and specifying reinforced concrete led control and economy to the architect once they were removed in a larger capacity on site. So here's a truck that has the AGCA symbol, so the contractor is now the primary agent on the site. And if early specifications written from the company supported the exclusive selection of Guastavino work, then later specifications begin to indicate how the company began to lose their hold, their exclusive holds, first of all, over Guastavino work and over their own labor on site. The political nature of specifications, again, it lies in their capability to select, displace, or even to disregard certain types of work. And beyond the three types of specification categories that were discovered for the Guastavino Company, a fourth type emerged, and that's Guastavino as subcontractor. And the subcontractor title assumed by the company in these later specs, it indicates a larger and broader disengagement between architects and the tradespeople. The Guastavino Company in this specification format, they were referred to as a subcontractor, which altered their social relationships with architects on the site, and again, it removes the exclusive selection of their work. Westward Senior High School is one of the company's final projects. It is one of the final three projects that are in the archive that include specification. And it's also a specification that refers to the Guastavino Company as subcontractor. This type opened work to other subcontractors in the trade and other trades. This project, which was completed in 1960 in Westwood, Massachusetts, by the Coletti brothers, is a two-page document that's entitled Section 16 Acoustical Tile. It's formatting subcontractor work according to work to be done, relationship with work of others, workmanship, materials and description, installation, and cleaning. So this excerpt here is included under materials and description. And the passage, it reads what the subcontractor should do. So first of all, the subcontractor shall Furnish and install 3/4 inch by 3 inch kiln dried softwood furring, strapping placed 12 inches on center and shin level. All right, this is an odd material for the Guastavino Company to use. They should be fastened 8 inches on center to the underside of a concrete slab using Ramset Remington or approved equal fastening device. Install all ties with collar nails at least ½ inch longer than tiles to wood strapping. We're seeing new materials being introduced here. Collar nails, reinforced concrete. And that's because the drawing that accompanies this specification is this. Guastavino tiles are right here, and they're being nailed via wood furring to a reinforced concrete structure. The system is no longer specified as a structural system. And what we start to see is that the company's role is changing in the construction industry. Reinforced concrete is now the infrastructure that provides the base for the acoustical tiles to be nailed into. And this reduces the work of the company to a decorative finish. And it also displaces the skilled labor of structural Guastavino work, which is primarily forming the bulk of their early 20th century work. Now, 1960, it is no longer the case. The specification, the second page, goes on to describe the relationship of the subcontractor to the general contractor. And throughout this specification, subcontractor and trade, they are the only terms used to describe or refer to the company. So Guastavino is out. It's no longer being used. This offers references to performance of the work. And as I said, as the specification continues, it says this subcontractor shall do such preliminary work in connection with work by other trades as to prevent delays to the general contractor himself and all other subcontractors. So if you remember back to the Cornell War Memorial specification, remember that the role of the stone contractor, the materials, and the general contractor, the role of each were there to support the Guastavino Company and their work. Now, the Guastavino Company is there to support the general contractor. And the primary objective here is to prevent delays. Because, of course, the general contractor is forming a single contract with the owner, and they guarantee a price, and they're guaranteeing a delivery date. So it's the responsibility of the company to make sure that they are not impeding on that original agreement. The terminology used within the 4 types of specifications that were categorized from the archives of the company, the ones that are written for the company, they reflect standardization and professionalization in the early 20th century architecture and construction community. Guastavino are similar, Guastavino in the title, Guastavino only. These original specifications that were written early on, before 1940, they established Guastavino work as a skilled labor to be performed on site. And the company was supported by stone, masons, contractors, general contractors, and materials. Standardization through testing and optimization of uniform building materials. And it wasn't just reinforced concrete, or steel and other industrial materials are optimized, as well as the rising professionalization among architects led to altered social organizations on site. And this is reflected in specifications written after 1940. When we see Guastavino as subcontractor emerge as a categorical type, it still gives agency to architects to select methods of work, building systems and materials, but the term subcontractor is the referral now. And it reduces the work of the Guastavino Company to something that is non-exclusive, it's typically decorative, and the work is there to support the role of the general contractor and their priorities, which is primarily a guaranteed delivery date and a price. The precision in defining and categorizing the work within written specifications is still leveraged as architect's direction of work. So when they're away from site, this is something that they were able to use, that they could write directives even though they weren't on site. But it also displays the selection of work that was performed by companies like the Guastavino Company. As their work was selected less and less, it likely led to the company's demise. One thing to note is that the company, it shuts down post-creation of the Construction Specification Institute. So what I'm showing here is the original master format, which was issued in 1960. Perhaps if this was something that, if the company had continued, they may have had their work qualified under Division 4, Masonry, but it was something that never appeared within the specifications that I had studied. So the development of the CSI is offering a less direct impact on the demise of the company, but certainly they're there to establish standards which reflect the restructured nature of the architecture and construction community. As an unexamined medium, specifications are sometimes often excluded from analysis in lieu of buildings, building systems, or drawings, which are largely considered the primary work of the architect. Yet specifications, they offer political agency in the agreements made to select methods of work, building materials, as well as systems. By examining these specifications, as well as the projects of the Guastavino Company, who were a 20th century master building company, turned eventually subcontractor, by examining the specification, it not only reflects the impacts of standardization and professionalization in the architecture and construction community, but also the political nature of specification work. And again, this is work that is continuing to develop. The Guastavino Company is a single case study in this story. And those specifications written for the company's projects emulate current ubiquitous frameworks. The specifications predate the Construction Specification Institute and master format, which was, again, issued in 1960. And it's the CSI that offers current writing and format standards. And in contemporary architectural production, the growing complexity of building technologies and their management has already expanded the CSI's original master format from 16 to 50, and perhaps in the future more. Methods based on digital production, automated labor, and big data have and will likely continue to impact the growth of master format. So of course what this means is that there's more work to be done in understanding specification as one of architecture's most social and political acts. And this is part of the work that I do with my partner, Federico Garcia Lammers. We started this project. It's called the Invisible Workflows Project. Here's the website if you'd like to go for it for more information. But this is a platform where we have brought collective work on workflows together. And what we define workflows as, it's the binding of material and immaterial systems that make architecture a form of cultural production. So these are some of the people who are involved in the project. And as I said, the work is continuing to develop. And if you want to watch it, see it develop, then this is a good platform to check out. Thank you for your time and attention and listening to me speak about specifications.
Thank you, Jessica. You can take some questions.
Yes.
Okay, well, firstly, thank you for a really, really compelling lecture. I'm especially taken with the way in which you've articulated how specification, so in a way the labour of the architect is absolutely imminent to the political economy of construction labour as well. And I think one of the reasons it's really compelling to me is because of my own interest in contemporary architecture and labour. And so I'm going to ask you in a second for some reflections on that from yourself. But I'm thinking, of course, of where we are now in terms of, for example, Eisenman's project in Santiago de Compostela, where it's the material specification, construction specification that has halted the project because the alternative is to bankrupt the city, bankrupt the civic authority, or more dramatically, really, the case of construction work in Qatar, which is actually undertaken under what Amnesty International recognise as conditions effectively of slave labour. And Zaha Hadid, God bless her, when she was asked about this, what she thought about the fact that there had been 80 deaths on the construction sites where the project was being built, and she said, well, that's nothing to do with me, I'm the architect. So those are only the most dramatic examples, but I just wonder if you wanted to elaborate on what you think let's say, put it in a positive light, what might a contemporary architect do to address, if it's at all possible, to address things like the skill and de-skilling and safety of construction workers?
Right. I think that, of course, as specifications, they offer a lot of agency to the architect. And I think the first thing that architects can do is to first of all acknowledge the political nature of the spec, and to perhaps not pass it off as just another legal requirement. That it is actually it's something that's so much more. I've read Professor Fritz, I've read your work on Fordism, and of course, it's been a part of this of my bibliography for this work. But I think ultimately this becomes perhaps an activist called, first of all, just recognize that I was just speaking to Ed about the fact that in South Dakota we don't really have a chapter anymore for me for the CSI, right? And so I think that what ends up being put forth as the architect's work is, I think, what Zaha said, it's the drawings, right? It's in the built form, and but specifications are the work of someone else. I think when we can recognize these forms of agreement first, and that's what we really have to do, is to recognize them as forms of agreement. That it's really documents like specifications that give architects agency to perhaps have these relationships on the site. Another project I'm thinking about is the Museo de Coches in Lisbon, the Coaches Museum, which is constructed of these huge steel trusses, and it was originally supposed to be constructed using reinforced concrete. But again, there was I think an uprising that happened with some of the labor unions, and instead switched the material composition went to steel, right? So it's something that can be reflected in documents like specs. So I think that the first step is to say, yes, this is what gives us agency as architects. These are political, and if we select something, what else are we excluding? What type of labor are we excluding as a result of that selection? And I think that's a really perhaps socially conscious thing to do. It's not that hard to say that the political nature of these documents is in selecting work is that it's eliminating work, right? So in that elimination, I think that's where we perhaps have to be more conscious.
Yeah, it's interesting how we've kind of gone full circle on this. You being a University of Minnesota grad, for 4 decades, there was the Minnesota Form Act. It was 41 divisions, rather prominent here in the Midwest, but never really got to the coast particularly. I know my dad was an architect in Davenport. It took me a decade to convince him to switch to the 16 division format, because that's the way the industry was going. But now when we look at it, I think he'd be rolling over in his grave now, because we're now 50 divisions. And part of the reason that that's taking place is to tie it into the BIM, building information modeling, so that you're dealing primarily with attributes of the given product. So you can manipulate that and tie it all together. So it doesn't specifically say that you're dealing with a specific manufacturer. It can be melded together like that. Where this is going to go in the future, I know, it's interesting. You guys are going to get to develop all this, because it's so dependent on the attributes now. If that attribute is off a little bit when you're selecting a product, it can mess up the whole project. And that's part of the problem we've been having a little bit. There isn't standards for those attributes for particular products. So we're starting to work on it now. CSI and NIBS, the National Institute of Building Sciences, are starting to establish those attributes. So I think probably within another decade, that standardization will be to the point that it'll almost be automatic for architects to be able to think globally. Language doesn't make any difference as you're talking in terms of attributes of a product. I think it's exciting for you guys, especially.
Yeah, I think there's a lot of certainly questions that exist around it, because I think one of the things that happens, and what I've noticed, is it seems that more specifications are becoming more product-based. In fact, I had worked for this company when I was in New York called Spec Simple. And our job was to create a database that would collect specifications for building materials and products. And as I mentioned in the lecture, one of the things that was really interesting about the Guastavino Company is that there was really not a lot of repetition among the specs in clauses used to describe the work. That each specification was very unique. And my partner, he looks at a lot of your DSA, the Uruguayan engineer. And one of the things that DSA said is, he said, well, if you look at architecture today, architecture really works as an assembly rather than construction. Right? It's an assembly of products and materials on site. And so DSA, as a Uruguayan engineer, was very interested in how constructions could work. I think the biggest question in this is perhaps going back to Professor Spencer's question of how automated labor is specified, right? That's a whole new area that perhaps may expand in the future. I think those questions are really interesting. In fact, the review that I sat on today was perhaps a great candidate for beginning to address some of those questions. But I think this point that DSA makes about buildings and architecture working more as an assembly versus a construction is a really interesting one, in that perhaps we've devalued the skilled labor that master builders were able to bring to site.
Got one over in the chief seats here. That's good. How are you?
I'm well.
I would just say that I totally agree with this and the other comments, and linking them together is the idea that specifications, either through the change in the formatting system or now to the going towards BIM, being product-based, being assembly-based, taking the means and methods out. Performance-based, it has to be this strong, this, right? It has to be this stiff. It no longer says this is how you put it together.
Exactly.
And the reason it says this is no longer how you put it together is because of the system you rightly pointed out of contracting and subcontracting, which goes back to a public bidding process in which you no longer can just say, in certain situations, this person gets the project, right? That formatting system allowed it to be more open to more bidding, to sort of cheapest labor, which then gets exactly right to this sort of full circle of it. In other words, the specifications are meant to be not about how we build it, let somebody else figure out how to build it. And in doing that, it of course marginalizes any involvement we have in standards for how to build it, except for its performance as an assembly, right? And I think this is a terrific summary that you made and showing how the architect's involvement with the means and methods, particularly Guastavino, was so marginalized, right? Where that was so based on the kind of means and methods of it, or they'd say, don't worry about the means and methods, just hire us.
Right, right, exactly. They're very, very good. But I think it's an excellent point, right? Is that was the responsibility that we gave. And again, back to this question about what's going to happen, right? Digital fabrication, I think it reinvigorated some of those questions of who's liable, who's responsible. And so this is something that's also, I think, on the table in future discussions. So what we see with specifications, I think it's most likely going to change, and I think the CSI is making room for that. That's at the end of the format. But I mean, it's what 2000 is when the divisions expanded. So if you think your 1960 to 2000 is 40 years, right? It took 40 years to expand as building technologies were expanding as well. Right? So I think you're absolutely right. This question about means and methods is a really important one that I think we have to ask ourselves once again.
I think so too.
Thank you for your presentation. It reminds me of what I work with national installation and asset design strategies in buildings, which were basically ruled out at the same time when these guys got bust in the 60s because of standardization of interior environmental conditions. As you know, the anti-thermal comfort standards, a very narrow zone, eliminated all opportunities to let the building flow back and forth with their thermal conditions and a little more humidity or less humidity, which, you know, when now we're bringing that back because it actually helps us save some energy and save maybe potentially reduce the carbon emissions of our build work. But that what you can't quantify, you can't build, is part of that whole development from the 40s into the 70s. You can't quantify, you can't build, it's eliminated from any discussions. So objections of architects at the beginning, but then let the machine do the job.
Yeah, I think these initial objections, like I said, the Cask-Gilbert objection in 1916 is a really fascinating one because it's perhaps a moment in history that we think never happened. And it's of course this question of like, why didn't we do this? Why didn't we stop it? Yes, there was committees formed. There were ways to try to stop it. And you're absolutely right. What happened with the standardization is it became so narrow in its requirements. Perhaps it's something that needs to be. I mean, I think yes, it needs to be re-examined again. And I'm not sure. I would love it if the AIA would. I would love it if the AIA would. I'm not sure that they're going to. Perhaps it's going to require the work of architecture lobby to look at this type of issue. I don't think that the AIA will. It's my challenge to them.
And that is a very social and very political beast.
Yes.
And the organization that is, as much as anything else, is responsible for us no longer having anything to say about means and methods, privilege and liability over knowledge. Well, should get going on that.
Right, it's a whole other discussion, right?
Please join